Okay, everyone. In today's lecture, I aim to cover uh, what would be the main topics that you're going to study for your exam. I have explained them in the last lecture, but I will do it again. I will tell you all those topics. I will be very quick. I don't want to take your time so that you can go and prepare yourself. And at the same time, if you have any questions, you can ask me. But I will briefly go through that. What topic you should be aiming to prepare for your final exam. You know that overall we have AI and signal processing. There are two parts of the module. Out of those two parts, you will be having four questions in total. So you have question 1, 2, 3, and 4. Two of these questions would be from signal processing part, and the other two would be from the AI part. Uh, so how the question paper would look like? The question paper would be, for example, you have for example, you have question number 1, then there is a possibility that you have parts for this. For example, part number A, part number B, part number A can be one question, and then there could be subparts. Subparts are not something, these would not be completely different. This would be something that I'm going to ask to find. For example, I can say, okay, find A naught, I can say find AN. So this could be number 1, number 2. And similarly, question number 2, there can be several parts and subparts. But as I said, that two questions would cover, in each question is 25 marks. And two of them, half of the paper would be from signal processing and half of it would be from the AI. Now, the question is that what topics are very important that you should cover and would be enough for your exam. So you know that from the beginning we started with signal processing course, and we talk about different kind of signals, but there was an important thing that I would like you to cover is analog to digital conversion, ADC, and digital to analog converter. One thing you should all know that the paper, there is no theory, it's only problems, it's only numerical questions, so there is no theory at all. So this is something that I would like you to cover. We have studied analog to digital converter, we have studied digital to analog converter. Just to give you an idea, you can see the slides on my screen, right?
Yes, we can see.
Okay. Okay. So you can see that we covered this part where we said that, okay, we are going to do analog to digital conversion. And then we said that, okay, what are the different parts? And then we also move towards, for example, if you have a signal, how to convert them into different levels and reach to certain point. Then there was a very important bit, which was digital to analog converter. So if for example you have given a digital signal, which is, for example, 000, and you have been asked to convert it back to the analog signal, then you can use this formula. If you are provided with this specific circuit, then you can use this formula, and you can see that if, for example, you have 000, then you can put in the same formula, and you can find the analog value. Similarly, if you have another input, then again you can put everything in this formula, and you can find the corresponding analog value for the digital signal. But the important thing, what is important thing here is DAC implementation using weighting summing. So it means that if for example you are given with this specific circuit, then this would be your equation, and you need to put all the resistances, and then you come to the final equation. So this is something which is very important from exam point of view. So I would say that you should cover this part. Then we covered Fourier series, Fourier series. And as you know that I told you for phase test that you only need to cover trigonometric Fourier series, in which you normally find A naught, A n, and bn. Still it holds. You don't need to cover the exponential Fourier series. So exponential Fourier series is not included. You only need to cover the trigonometric Fourier series. Now, how the questions would look like, you you already have a flavor of it during your phase test, that you would be having a question, then probably you would be asked to find, if for example you have a graph. For example, if I have this specific graph, pi 2 pi, then probably you would be asked to find the equivalent f of omega t, and then next step you would be asked to find an, a naught, an, and bn. So this question would be similar to what we have in the phase test. And as I said, that if you cover what we have covered in the lectures and tutorials, you would be fine. But from Fourier series, you don't need to cover anything else. You only need to cover the trigonometric Fourier series. Then another topic was the Fourier transform. Yes, so you need to cover Fourier transform. And finally, we studied Laplace transform. We covered inverse Laplace transform. And there was very important bit that we covered. It was system response using Laplace, which was, for example, impulse response, which was zero state output, zero input, output. So these were, and if you remember, we covered all of this. We covered some questions for inverse Laplace transform, both in your lecture as well as in your tutorial. And similarly for this part, again, we covered questions in your lecture. We did solve some of the questions, and also you are having questions in your tutorial. So I would say that if you're good with solving the questions that we solved in the class, then and same, if you're good with solving questions that we covered in the tutorial, then exam paper would be very easy for you. But it's very important that you should know that how to find Laplace, how to find inverse Laplace. You also know that we had similar question in the phase test, but the very important bit here is the system response. So this is very important, but also mean you have to cover Laplace, inverse Laplace, but this bit comes as very important. So overall, from the things that I have mentioned, for example, analog to digital, digital to analog converter, that you have Fourier series, then you have Fourier transform, then you have Laplace transform. So overall, you will be having two questions from the signal processes. So it's mean that this whole these whole topics that I have mentioned, your question would be formed of these. So it's possible that in it's possible, for example, in question 2A, you having Fourier transform, and part B, you having a Laplace, and so on. But overall, the signal processing part would be only 50 marks. Yeah, this was for the signal processing part, and I guess I have very narrowed it down. And again, you don't need to do any theory; it's only numerical questions that we covered. And yeah, now moving towards the AI part. As you all know, that in AI part there were theory things and so on, but as I said, that it's only numerical questions. So the question that could come from is very important: search algorithm, search algorithm. So you know that we have breadth first search, we have depth first search, we have A star search, we have heuristic search. Excuse my spellings, but yeah, we have heuristic search. You remember that in this case, if for example you have a start point, then move towards point A, then move toward point B. Similarly, you have point C, and this is your goal. So you could have similar question and you have been asked to find path, what path this algorithm should follow. When you have a breadth first search, what path should an algorithm follow? And if you remember, we covered these in lectures. So you will not see anything in exam which we haven't solved. So there is a possibility that the questions are slightly different or something. But if, as I said, if you're covering your lectures, your tutorials, you will be absolutely fine. And an important thing here to mention is that you do know that in heuristic search, we came to know about two things. One was admissible search, and the other one was consistent search. So you should know what are the conditions for this. So it's very important that you should know these conditions, because when you're going to solve, if you remember, we solved a few questions in the class where we said, okay, tell that whether H1 is consistent, whether H1 is admissible, and then you know that there is a small condition for that. And if that condition is satisfied, it is heuristic, it is admissible or consistent. But clearly you would be having one question which would be roughly of 25 marks from the search algorithm. And you know that this if you know how this certain algorithm work, you can clearly answer the question. And as I said, if there is written that you have to find what path BFS should follow. So, for example, if I say SABG, I'm just taking an example. So you have to give a path, but if it is mentioned that you have to give a reasoning too, then you have to write something. For example, you will say that, okay, breadth first search, go to from one node to another node, and then it it at the same time it So in case of breadth first search, so it goes here, then it goes here, then here, here. So you need to explain. So if you have been asked to find the path and also give reasoning for your answer, so you should be able to give some reasoning, and you know how to give reasoning. In case of depth first search, you can say that, okay, it will follow the extreme left path towards the end until it finds a goal, and if not, then it will come and it will follow other path, and so on. But it's very important that if you have been asked to find the path by a certain algorithm, and if you have also been asked to write a reasoning can be one line, but it is very important that you provide reasoning. If it is written that you have to find the path, and you have also you have to provide the reasoning, and if you are only writing the path, and if you're not writing the reasoning, then it clearly it's mean that you will get half question. But if it is only said that you have to find the path, and it is not mentioned anything that you need to find any reasoning. But if it is said that write the steps that how you reach to your point or something, then you have to write some reasoning with it, that is how you attained certain path, what was the logic behind that. Okay, then Okay, then the other important bit that would come from AI is something which I guess only few students attended the last two lectures, which were very important, is Bayes Bayes theorem, which is if A given B equals to probability of B given A into probability of A, wherever probability of B. So the other question that is the second part of the other bit that comes from AI would be from Bayes' theorem. So you should be able to know that how you find the probability, how you apply the Bayes network. So in this case, I would emphasize that you should go through the lecture. Marginalization is very important. What is marginalization? Marginalization says that if you want to find probability of A, then you have to consider all the cases where A is true. So A and B plus A and not of B. But if, for example, you have many other conditions. So if, for example, I say I have to find the probability of white ball, given you have box number one, box number two, and box number three. So probability of white ball would be equals to probability of white ball and H1. If there is no H1, who else is true? Probability of white ball and H2 plus probability of white ball and H3. So this is marginalization. This is very important. And the second thing that is very important you need to look at is the conditioning, because marginalization alone may not be helpful in some cases. So what is conditioning? Conditioning comes from marginalization, which is P, A, and B plus probability of A and not of B. So if you don't know A and B, we do know that it is equal to probability of A given B into probability of B probability of A given not of B into probability of B. So express these and things again using the conditional probability. So using conditional probability, we use this. So overall, this marginalization turn plus conditional probability will give you a new thing which is called conditional rule for probability. And again, if in this case you have to find probability of a white ball and you have box number H1, box number H2, box number H3. Why I'm giving you example for H1, H2, H3? Because in the first case you have A and B only. So A and B plus A when B is not true. So in some cases, this is not always possible, true and not true. There are many, for example, if we say that we have no rain, we have light rain, we have heavy rain. So if someone asks me to find the probability of cloud, so I will say that, okay, probability of cloud and no rain plus probability of cloud and light rain plus probability of cloud and heavy rain. If it was rain and no rain, then it would have looked like probability of cloud equals to probability of cloud and rain plus probability of cloud and no rain. But if you have more than one condition, when true or not true, then you have to consider all those conditions. So what if I write for white ball? So it would be probability of white ball is equals to probability of white ball and H1, probability of white ball and H2. Sometime comma is also considered as and probability of white ball and H3. So you have to consider all other conditions. Okay, so if I remove this and if I express the same thing in terms of conditioning, so you will be having probability of white ball is equals to probability of white and H1 plus probability of white and H2, probability of white and H3. So we can write it as probability of white given H1 into probability of H1. Conditioning is very important. In some cases, you will not know what is this and thing, but you would be knowing something else, which is the given probability. So that's why it is very important that you represent the and terms in terms of conditional probability, and it's possible that you know the conditional probability. Then there was another bit that I want to mention, that if you know that probability of A is something 0.2, and if you don't know probability of not of A, so we simply say 1 minus probability of A, which is the probability rule. Similarly, if you have something probability of B given A, so what is probability of not of B given A? It would be 1 minus probability of B given A. But this is important to mention that this holds only when the given condition stays same in both of them. Only then this is true. Similarly, if for example you have probability of B given not of A, so if someone asks you to find probability of B not of given not of A, it would be equal to 1 minus probability of B given not of A. So it's mean that these are very important things, and Bayes theorem is very important. We covered several examples in the last class. I also uploaded step-by-step solutions for some of the exercises. I would recommend you go through it. But overall, yeah, this would be the narrow down version of the course that you should cover for your final exam. And now, if you have any question, I would be more than happy to answer. Is anyone having any question that you want to ask?
Yes, Zahib, I have a question. Do you know the pace that just the way you explain at the moment?
Mhm.
You know the lecture. Do you got some examples there, and you also give a solution for that, and if I practice that, it would be okay for the questioning part for
Y-
this one.
y- Yes, that would be okay. If you cover what I have explained in the class,
Yeah, of course I have.
uh, and the examples that I have uploaded, you will be fine. Yes.
Okay, okay. Thank you very much.
But
Because I
if
missed la.
yeah, if anyone, for example, who missed this class, if you still have any issue, and if you want to come over, you're always welcome. Just send me an email and come over sometime, and I could explain your QDs if you have any.
Appreciate it. Thank you very much. Appreciate. I'll go through it.
Yeah,
Yes.
okay,
Thank you.
perfect. But overall, yes, if you're going to cover all the questions, all the tutorial questions that we have covered class. Normally, you know that whenever I cover in the class, I give indications that how your final exam would look like, what type of questions you should cover, and things like that. So I guess if you're good at what have we covered in the class, what we have covered in tutorial, you will be absolutely fine in your exam. Another
Also, I have a
thing,
question.
sorry, yes,
So,
go
uh,
ahead, go ahead.
this is recorded, right?
Mhm.
Okay, cool.
I think so.
It says it's
Yeah,
being
it
recorded.
is
Let me
recorded. Yes,
confirm.
it is recorded. Yeah, that would be fine. Yeah.
Thank
Um,
you.
Another thing is that uh, some of the students who have not received good marks in the face test, um, there is, they can improve their marks by appearing for a resit. Normally, you know that resit period is in August, but if someone is get good marks in the final exam, then he would be passed, but he would get less marks. So what I can do is that for a student who probably failed their face test, who received less than 30 marks, they could appear for face test again. I can leave this open. If you want to appear for some day after your final exam, then even that is fine. But I really want, if whoever failed his face test, please write me an email, and we can arrange a reset for the face test. Okay. Right. What else I wanted to cover? Yeah, I guess this is it. If there's anything else anyone wanted to ask, you can always send me an email, and I would be more than happy to help. But do prepare well and cover all that we have. Yes.
Also, I was going to ask you in regarding about the. Do we have any other tutorial in regarding for probability? Because I didn't see any tutorial in that. It's only lectures now. Like a
Um,
tutorial question for probability, it
uh,
would be helpful.
did you attend last lecture?
Unfortunately,
No, I'm
I
just
did
asking.
that.
Did you attend last lecture?
No, I didn't
No.
because I
Okay,
got.
no problem. So if you go through the slides for the last lecture, so in the last lecture we did cover several questions, so that would be okay for you.
Okay,
And
thank you.
give me a second. I will probably jump into that. No problem. If I go to base networks, so you can see that solution to class questions. There are some questions which I solved in more detail. You can see this, and also if I go to the lectures,
Let me have a look. Really.
so you can see that we covered this example in the class. Then we also covered this second example in the class. Then as we moved ahead in the end, again we covered few questions. So yes, this key question with Bayes rule, then this example with Bayes rule. Yeah, so if you cover these, it will be fine. The last two questions of the lecture slide, they are actually provided in the PDF, step by step. But the other questions, the questions which are in the middle of the lecture slide, for example, this problem, this is explained in this slide, and also this second question, again, this is explained in this slide. And this question, these questions are more or less similar to the last question as well. So you do have enough questions to prepare for your exam. Okay.
Yeah, absolutely.
Can you see my
Thank you.
slide? Can you see my
No,
screen?
no,
Oh, no, sorry. Okay, I thought you were looking. So you can see that. Can you see my screen now, right?
absolutely. I don't. Yeah.
Yes? Okay, now you can see that in on slide number 10 for the last lecture, we did cover these questions. Slide number 10, slide number 11, slide number 12, 13. So these are the two tutorial questions that we covered. And then also in the end of the slides, which is slide number 40, 40, 41, 42, 43. So we also covered. So overall, we covered 4 or 5 questions. And these last questions on the slide, they are also uploaded here. So you have this, these two. So uh, I would recommend first, those who missed the lecture, I would recommend first solve the last two questions because you have step-by-step solution in the PDF. Once you are done with that, then go to these middle questions, and once you have solved those, this would be very easy to solve for you. Okay.
Okay, thank you.
Also, you know that you have to submit your logbook, so you have to submit it before your exam. I guess when is your exam? 23rd. Oh,
25th.
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 25th. Yeah.
And the logbook, you made it on Saturday, which is 13th of May.
Yes, yeah, but as I mentioned last time, that if you feel that you need a bit of more time, that's not a problem, but you must submit your logbook before your final exam.
Okay.
Okay? I will not care or do anything, but you must submit it before your final exam. Okay?
Thank you very much.
Yeah. In the
Appreciate your
meantime,
help.
no,
It
no,
was
no
very
worries.
helpful, your subject, and I hope everybody else will like you,
No problem. Thank you so much. Yeah, thank you. So kind of you. Okay, I will leave you in peace, and anytime if you have any question, anything before exam, just write me an email, and I would try to be quick in responding. And if you need anything, you can always come to me, and I would be helpful, hopefully. Okay, good luck, guys, for your exam. I wish you best of luck and prepare well. Okay.
Thank you very
Thank you.
much, sir.
Thank you.
Thank you
Bye.
very much.